Hello, so today we're going to talk about graphs of polynomial functions and more specifically zeros and factors of polynomial function. So if you can turn to page 10 in your Unit 2 packet, you'll see that there's 3 graphs on this page, okay, and I just want to quickly talk about them. The first one is called a quadratic. A quadratic is a polynomial of degree 2. Okay, so this graph actually has this equation right here. So if you look at this equation, see how the biggest exponent is a 2? That's what we say, that's what we mean when we say a polynomial of degree 2, okay? This is our biggest exponent. But whenever you have a second degree polynomial, it graphs to look like this, a parabola, okay? It looks kind of like a happy face, or if you were to flip it upside down, a sad face. Okay, the next graph is called a cubic. A cubic looks like this. It either goes up, or it could go down, up, down. Although we'll see sometimes there's different variations. But a cubic is a polynomial of degree 3. So see how here, this is actually the equation of this graph. See how here our biggest exponent is a 3? Okay, when your biggest exponent is a 3, we call that a cubic. And this is what a cubic graph looks like. This down here is called a quartic, okay? So this is the equation of this graph, and a quartic is a 4th degree equation, okay? The biggest exponent is a 4. So a lot of times it looks like, kind of like a W, or if you flip it upside down, right, it looks like an M. Okay, so now if you can flip to the next page, we are going to talk about roots, zeros, and solutions, okay? These terms can really be used interchangeably. They refer to the x values at which the function intersects the x-axis. Okay, so let's look at number 11. Now, if you look at number 11, look at this function. Okay, what is this a picture of? Look back on the previous page if you have to. Okay, this is a quartic. It's a 4th degree function. But they just want to know, they're asking in the question here, right? Which set lists all the roots of when f of x equals 0. Now the roots, remember, the roots are the x values at which the function intersects the x-axis. So we could see that the function intersects the x-axis right here at -2, right here at 0, and right here at +3. Okay, so -2, 0, and 3. So our roots would be choice 4. They could have asked for the zeros or the solutions as well. Okay, any of that terminology would bring us to choice 4. Okay, so now let's take a look at number 12. It says the graph of h of x is shown below. So they first want us to determine the roots. Okay, so the roots are just like we said in the previous one, where the graph intersects the x-axis. So we see we have one right here at -1. We have one right here at +2, and we have one right here at +3. So for part A, I mean, you could write out your answers a couple different ways. You can do it in curly brackets, like they did up here, okay, in number 11. So you could just literally just put them from least to greatest. You would say, all right, my roots are -1, +2, and +3. So that's an acceptable way to write your answers. That's a kind of funky curly bracket there, huh? Okay, the other way you could write it is you could just list out x equals -1, x equals +2, and x equals +3. So, I mean, either one of these are acceptable, or I'll leave them both ways. Okay, now part B says determine the factors. Okay, now what I wrote up here in pink, you do not have to copy this down. I'm just using this to show you how factors corresponds to roots or zeros. Okay, you know if you were given an equation to solve, right? The first thing we do is factor it, and then when you solve, right, we wind up getting x equal, from a factor of x -5, we get x equals +5. And from a factor of x plus 1, we get x equals -1. Okay, these are called your solutions or roots or zeros. See how the zeros or the roots have the opposite sign of the factors? Well, if we know, let's go back to our problem now. If we know that these are our roots or our zeros or our solutions, wouldn't the factors have the opposite sign, right? So if we have this, x equals -1, wouldn't the factor that corresponds with that be x plus 1? Right? It's going to have the opposite sign. If we have a 0 or a root at x equals +2, wouldn't the factor have the opposite sign? Wouldn't it be x minus 2? And then same thing here. If you have a 0 or a root of x equals +3, the factor would have the opposite sign. It would be x minus 3. So these right here are our factors. And I just want to point out something I forgot to say. Look at this graph. Do you remember what that's called? If you have to, look back on the previous page. That's right, this is a cubic. Okay, if you turn to page 12, let's pick an example off that page. Let's pick number 15. Okay, now this time they're not giving us a picture of a graph. It says, which binomial is not a factor of this expression? Now, to be honest, if I were to first read this, I'm going to make this a little bigger. If I were to first read this, right, I would think, oh, factor, let me try to factor this. So what happens is, if you do try to factor this, right, we have 4 terms, we're going to do grouping. I can pull out an x squared, which leaves me with x minus 11. And I guess out of these next 2 terms, right, I guess I could pull out, what, a 4? Which would leave me with 4x plus 21. Now, look at this. This and this, they do not match. They're not equal. So we can't factor this using grouping. So let's think about another way that we learn that we can come up with factors. Now, if we know what the graph looks like, and if we know where the zeros or the roots are, right, where the graph intersects the x-axis, then can't we use that to help us find the factors? So let's do that. Okay, so what I did was, in my calculator, I took pictures. I went to y equals, and I plugged in this into y1. And then I hit graph, and I looked at the graph. Okay, this is a picture of what the graph looks like. Now, if we look at the graph, right, we can see that there's zeros right here at x equals -2. There's another one right here at, let's see, 1, 2, 3, 4, 5, 6. And then there's another one right next to it at x equals 7. So these are my zeros. Okay, I have zeros at x equals -2, 6, and 7. And even if you didn't want to look at the graph, if you hit second graph, if you went to the table of values, look at this. At -2, the y value is 0. At +6, the y value is 0. And at +7, the y value is 0. So these are where my zeros are at. And we know the factors have the opposite signs of the zeros. So let me just write this out. So if I have a 0 at x equals -2, wouldn't the factor have the opposite sign? Wouldn't it be x plus 2? And then if I have zeros at x equals +6 and x equals +7, wouldn't the factors have the opposite signs, right? X minus 6 and x minus 7. So these are my factors. They want to know which of the following is not a factor. So we could see we have x plus 2, x minus 6, and x minus 7. So choice 2, x plus 4, that is not a factor. Okay, if you flip to page 13, let's just do one example from this page, one example from the next page, and that's it. Okay, number 17. Which factors are represented in the graph below? All right, so if we look at the zeros, you can see we have a 0 right here at x equals -3, and we have a 0 right here at x equals +4. So we know the factors are going to have the opposite signs, x plus 3 and x minus 4. So where do we see that? Choice 2. Now I want to point out, look at this graph. Okay, think about the first page we looked at today, right? What is this a graph of? That's right, it's a quadratic. Okay, it's a quadratic. It looks like a sad face, right? A quadratic means that our biggest exponent is a 2. So we're going to have x squared. This is y equals, something with a second degree equation. Now, if you look here, isn't x times x squared? So it makes sense that this would be a second degree equation, a quadratic. Okay, let's look at one example on the next page, and then that's it for this video. Okay, so on page 14, let's just look at the one on top, number 19. Which factors are represented in the graph below? So the same thing, let's look at the zeros. We have a 0 right here at x equals -5. And we have another 0 right here at x equals 2. Okay, so that tells us our factors are going to have the opposite sign. So the factors will be x plus 5 and then x minus 2. Remember, the factor, if these are zeros, the factors have the opposite signs. Now, think about this graph. Think about what this is a picture of. A cubic, right? This is a cubic function. Now, isn't a cubic function, isn't that x to the third power, right? That's a third degree function. But if I were to look at these two factors, right? Isn't x times x squared? It's not x to the third. So what that means is these can't be our only factors. So if you notice, see how right here at x equals 2, the graph crosses through the x-axis? Okay, when a graph crosses through the x-axis like this, it means we only have one factor. But if you look right here, see how the graph comes up? And when we hit -5, instead of crossing through the x-axis, it touches the x-axis and bounces back off, right? You might remember from geometry the word tangent, right? The graph is tangent to the x-axis right here. When your graph does not cut through the x-axis, when it bounces off the x-axis, we say there's something called multiplicity. Okay, I want you to write this in your notes, write this on your paper, and I'll explain what this means. So when the graph bounces off the x-axis, we say there is multiplicity. Now think about multiplicity. What could that mean? Multiple, right? Multiple, more than one. What that means is we have more than one factor here. So when a graph bounces off the x-axis, we actually have two factors there. So we have two factors of x plus 5. So I could either write the x plus 5 again, right? I could write x plus 5 times x plus 5 times x minus 2. Or what we do instead is we put a little square in this factor. Okay? The multiplicity tells us that we're going to have two of these factors. So it's going to be squared. Okay, so here, if you look at choice 3, isn't that where we see x plus 5 squared, right? This is the multiplicity of the squared, and then times x minus 2. So we'll see more of these tomorrow. I mean, honestly, if you look at the example below, look at 20. Right here at x equals 2, see how the graph crosses through the x-axis? That means there's only one factor. But right here, see how it comes down to the x-axis, and instead of crossing through, it bounces back up, and it bounces off of it? That means there's going to be a multiplicity, so it's going to be more than one factor here. But we'll take a look at that example tomorrow in class.